Welcome to Manufacturing Explained. My name is Greg Paulson, and I have spent my career using various manufacturing technologies to produce and deliver engineered parts. Manufacturing Explained is an expert-to-expert conversation on all aspects of manufacturing. I am joined here today by Matt Magnifico, a senior project engineer and injection molding subject matter expert at Xometry. Matt has a master's in biomedical engineering and a decade of experience in design and manufacturing. Matt also has a unique set of skills, because he has a holistic view of injection molding, wearing multiple hats as a designer, manufacturer, and quality engineer. Today, I want to ask him about the injection mold tool, where the action happens. Not just about how it's made mechanically, but how someone like Matt thinks about the tool based on a project's requirements, timeline, and even budget. Matt, welcome to Manufacturing Explained. So you went from being a medical assistive device product development and manufacturer into a contract manufacturer. What was the flip there? What was different about that role?
Yeah, so that was interesting. So, you go from seeing why we're making this part to all the details of, oh, I want, this to feel this way, or I want it to be this big to, someone comes to you and says, make this for me.
Make this, yeah. I want this.
And
what's the
work
price?
through it. Yeah. So it was, and the whole idea of that switch for me was I really enjoyed, CAD modeling, designing parts, and I just enjoyed, the manufacturing side of it. I enjoyed doing DFM, so I really kind of wanted to work on those skills and hone those skills in. So it was fun from the standpoint of, okay, so now that's all you're focusing on. But oh boy, can it get frustrating when you have no control over the design of the part. Like, you're designing it, you're physically putting it in CAD, but someone else says, no, I want this way. So you have to put away well, I think it's going to be best if we do this. No, customer wants this. This is what they're looking for.
Yeah,
So,
and I've seen that, contract manufacturing. It's an interesting beast because contract manufacturing, like there's spec manufacturing. So that's
yeah,
something
absolutely.
we, see day in and day out, where it is like I have my print, make it to print, and as a manufacturer, my goal is to make that a
Make that
success.
part. Yeah,
Or if I see a challenge, I'll give them like that DFM you mentioned, design for
absolutely.
manufacturability feedback. They do some light edits, we make it successfully for them. Contract manufacturing is kind of like make the spec, but I need engineering assistance or
Absolutely. If
supply
we're
chain
changing
assistance.
designs
Yeah,
too, like we need you to
yeah,
change the design. So,
yeah,
um,
yeah.
yeah, it flipped, and it was interesting, and it gave me a lot of, and going back to what you said earlier, like having the many hats of seeing it, kind of shapes things. And for me specifically, if you want to talk about flipping the coin again, so where I ended up right before Xometry was I worked for about 5 or 6 years for a plastics injection molding company where we didn't have the design. We did some DFM, but like it was just purely here's the design,
You're
here's
given the file and
everything.
print, run.
Make this part,
Yeah,
in 32 cavities, let's make, 10 million parts a year. And it's more of, okay, so how do we design the cell? How do we design the mold? What do we put in place, from that aspect of, making a
yeah.
part successful?
Well,
What quality do we add? So,
and I'll slow down because when you talk about million part production,
yeah,
and this is something that I'd love to dive into this a little bit more because I think we want to talk about injection mold tooling today.
absolutely. Yeah.
And you mentioned this word cell, which is something that is not always
Yeah.
a thought or a factor when the customer comes to you, which is at a certain production level, you need to build peripherals to
Absolutely.
support that. Like, so this is a
Absolutely.
cell, by that you mean a work cell, and
Yeah.
that's stuff to handle, move, package, anything else that's
Yeah.
required beyond the physical that like manufacture process. Yeah.
Absolutely. So, like, depending on how many parts like you're making, the cell can mean a lot
Mhm.
of different things. So, when you're talking about an injection machine, injection molding machine that's running from start to finish from January to December and just never not making that specific part, even the injection molding machine becomes part of the cell. And like that,
Yeah.
you could wrap things around that. There's going to be robots to take parts out of the mold, put it on a conveyor belt to go do X, Y, and Z. Like, even as big as that can become part of the cell. So hi, make me this, small little widget becomes, an entire shop floor of space with
Yeah.
robotics and things like that. So down to, okay, well, we use the same press for, 100 different products, and then we roll up a cage with something that may sort things out or bag or package them, or, do some secondary process of install. Like that could be the cell as well. So it really
Yeah.
depends on the
And,
scope.
yeah. So you went with all this experience, and now you're at Xometry, and you're
Optometry.
kind of wearing all those hats again in
Yes,
some manner and form. Yeah.
absolutely. So it's really all of those insights: how to design a part, how to get things made, the process of going through a contract manufacturer, the process of building a mold, building the
Hmm.
cell, doing the quality inspections. At Xometry, um, we have all different types of customers. So a customer who has no knowledge of manufacturing can come to us and say, "Hey, I need to make this part. Here's my, model. What can we do?" And or we can have, Fortune 500 company come to us, has done this, many times, and has a well polished, this is exactly what I want. Make it happen. So going from a, place of where, and a mindset of this is a well polished something that I can have, to also, hey, someone knows nothing about injection molding, having to, switch over from one to the other and have the different conversations
Yeah.
while teaching someone what injection molding is versus this is what we can offer you based on what you're, asking
Yeah.
for. Xometry, we kind of are like that one stop shop for any of those
It's
customers to just come to us and get that, knowledge experience.
Yeah, it's the democratization of manufacturing,
Democratization,
the
absolutely.
access to I'm going to buzzword it up, digital marketplaces and all that
Yeah,
jazz. But it works. It's
it
very
does.
interesting. It's
It
very
does.
diverse. But
Yeah,
all right, any customer comes up to you though, so
yeah,
this has got to be kind of leading into some of these questions that I have set up for you. But what do you ask them? So when a new customer approaches you and they're looking to move to a molded product,
absolutely.
what are those key questions you ask? And ultimately, that's I'm going to follow on and ask you, like, how does that relate to strategy, like your
Absolutely.
production strategy? But what do you generally
W-
ask a
Let's start
customer?
with like what's the question. So,
Hmm.
one of the major question is, now obviously, where's the CAD, where's the print? Let's review that first, and then that usually leads to a whole bunch of questions and tells you how polished. I'm going to use polished, how polished the customer is in injection molding. So you can tell right off the back in a CAD file the level of knowledge that, the customer has. But sometimes they're working with a design firm that may have made them the part and they really still don't. But so
Hmm.
one of the first questions is, how comfortable are you in injection molding? What do you know about injection molding, and how can we help you get up to speed? So when we're using, terms, when we're talking about a cavity side of a tool, when we're talking about a core side of a tool, when we're talking about gates, when we're talking about injection, if the customer doesn't understand those concepts and those parts of the mold, we'll spend some time and educate the customer. So, we want to know their level of comfort of what we can talk about, so we can help them understand the risks and, uh, what putting an ejector pin, in a certain location, what's that going to mean for them. For someone who's done, 100 injection molding projects, they're going to know there may be some flash there. You're going to see the witness of where the ejector pin is, parting lines, what can happen there.
Yeah.
You can have
They,
flash and things like that. So
Yeah, and they may have a preference. I know
they
we
may,
have someone
absolutely.
who's doing some, and I know this is devices that you worked on before, where they're like, "I'm gonna do a bond seal here. Can we make it so an ejector bin doesn't exist in this location, or
Absolutely. Yeah,
we want to keep a wave zone?" And in another interview that we did on this podcast, when I was speaking to Scott Benson, we were kind of talking about a lot of times ejection is more up to the tool maker, or
absolutely.
it's more like usually a designer's not sitting there being like, I'm going to figure out how to eject this
Yeah,
part,
no,
because there's a lot of plays, but they can have preference. They can at least
absolutely. Absolutely.
have asks that we want to listen for. Hmm.
So yeah, so again, a print or a drawing will tell you a lot of that. If they're talking
Hmm.
about, ejection, or they're talking about flash or parting lines on a drawing, you have an idea. Okay, this person understands. Don't put a parting line there. Well, okay, good. We're not going to put a parting line there. If not, we're going to ask those types of questions. And again, based on their level of experience, can you have flash in this area? If they don't know what flash is, obviously we'll say, can you have a little bit of, hairline material, here, or does it have to be completely clean? Is someone using gloves when using this product? Things like that. Trying to understand what the design intent of a product is so that we can kind of then use our expertise, which again, it isn't specifically manufacturing and injection molding, to say, okay, well, we can do this or we can do this. This is what you're going to get with A. This is what you're going to get with B. What works best for you, and we can help guide, to those specific situations. So, definitely comfort and knowledge about the product, and knowledge about the process in general is one of the major questions. The next kind of large questions that we get into specifically is, okay, well, how many parts do you need?
Yeah.
And that's always a huge conversation, right? If someone only needs one part, are we making an injection mold? There's specific cases where they may only need one or two parts, but it has to be injection molded. They're doing some sort of testing or proving out a concept to move on to larger injection molding. Maybe that's the case. Usually it's not. We can urethane cast or we can 3D print, part and have that same kind of result to make a plastic part.
Yeah, mill the shape sometimes if you're able to
Absolutely.
get that material. Yeah.
But then you get into, okay, well, I need a couple hundred parts and then I'm done. Or I need a couple hundred parts every month.
Yeah.
Or, hey, I need tens of thousands every month. I need millions of parts off this mold and I need it to last as long as possible. Those then all lead into, how am I going to construct a tool? How am I going to construct that mold? So that question of quantity, intent of, how many of these parts they need, when they need them by, how fast do they need them by?
Yeah.
Those questions, then drive some more thought into, okay, what kind of materials, metals are we using for the mold? What processes are we going to use to machine the molds? What changes do we have to make to the part to allow those, processes to be successful? So those are some of the big, questions that we use.
So let me dive into that, and maybe I think something that could be kind of interesting is run some scenarios by you, because we mentioned some of these, and how would that affect your tool approach? And
Absolutely.
I know we're kind of blending some of this together, but also if you could kind of over explain on when we talk about some aspect of the tool the first time, I think we can really blend this in. But say I'm new. I'm newer to injection molding, and I'm trying to succeed in my Kickstarter campaign. So my product is probably the initial rev is what those initial customers are getting. So that's a rev, is part revision. Very likely the revision is going to change. So my tool life, or my goal is to get about 2,000 shots out of this. But I need to at least get my Kickstarter winners of the initial 350 or whomever they're getting, but maybe 2,000. When I tell you that, like, what goes in your head? Like, what type of strategies are in your head?
Right off the back, if you tell me this is a early stage Rev 0 kind of part, and that most likely we're going to have to change it, we can attack that from a couple different strategies, right? So one, in material selection, maybe we go with a very quick, rapid cut, aluminum mud frame type of design. So what is
the material of the tool itself?
Material of the tool itself, but also not building an entire mold base, but utilizing what's called a mud frame, in which a majority of the components exist already, and then I build, the two halves of the mold only, in kind of mud frame blocks, and then I put those in the mold. So rather than having to machine 100% of the tool, maybe I only do the 50%, which is the A and B block. So let's go into that a little bit, I guess, to explain. So when you have a mold, right, it goes into an injection molding press. One of the parts of the mold stays stationary. That has a lot of different names. That could be the stationary side, the A side of the tool, the cavity side of the tool. This is where the injection of the plastic is happening. So this is tied to the machine and where the plastic is going to shoot into the mold. The other half of the mold is, we call it the B side, or the core side of the tool, or the movable side of the tool. This side specifically moves and opens. This is the side that moves and opens. So once the plastic is injected into the mold, the movable side moves away, and then pins or plates or bars or however we design the ejection system will then push the part out of the mold. Sometimes a robot comes in and grabs it as well, but that's the side where all the movement happens.
Yeah.
Right.
So when it's closed, it's the cavity's the shape of the part, right? Because the
Yep.
plastic's growing in, but like when it cools in shape, but as it opens up, and it's kind of interesting because the pins essentially stay still, and the rest of the tool moves back, and what that looks like is that the pins are pushing out the part and like evenly out of that part. Yeah.
Absolutely. So, if we were making a mold that's going to make 1 million parts, and it's, we're building an entire mold, right? So there's going to be plates that attach to the machine. There's going to be water lines running through it that we specifically place, for the part that we cut, et cetera. But for prototyping stages and early up front, we can use what's called a mud frame, in which a lot of that already exists. And then I build inserts that go into this mud frame, and I can have 10 different parts that can utilize that same mud frame and then go into that mold. So that's a more rapid way of doing it, more cost effective. Knowing that I'm going to change that part, that's one way to do it. Another way to kind of if we're talking about iterative changes, some people specifically have an area they know is going to change. 90% of the part is going to stay the same, but this one area, maybe it's a port for something, or maybe it mates to another piece, maybe that part is the only thing that they know is going to change. So I can build a mold the way I normally would, build a whole mold, build the A side, build the B side, but then I could put specific inserts inside the mold. And those inserts, we can design them specifically so that we can change those inserts. So let's say it's a water bottle, right? Mm-hmm. The opening of the water bottle. So let's say customer doesn't know whether or not they want the opening of the water bottle to be 1 inch or 1.25 inches. Okay, well, we can start with 1.25 inches, large steel, and then if we have to, we can now just change that one insert rather than replacing the whole tool, or we can machine down that insert. So that leads into a kind of like a conversation of steel safes. Sometimes a customer may not necessarily want to change the feature entirely, go from a square to a circle where you need entirely new piece of metal, piece of steel, piece of aluminum, but maybe they just aren't 100% on the dimensions. So maybe in cases like that, we leave a little extra material on the mold the part, measure the part, do functional tests, and then we can, machine off the material.
Yeah, and that plays a role too. So steel safe also plays a role with like critical dimensions and tolerances, where you want to. Yeah. If there is like it definitely like these two holes here definitely need to line up with this thing here. Yeah. And that's something and we were talking about some of that timeline when you have that T1 sample, you're verifying that, and hopefully the tool is made in a steel safe so that we could do light modifications called grooming often, where it's expected in the tool making process, so it's not necessarily an extra charge, which we would call like ECO or engineering change order. If there's like it's so dramatic that we just got to charge you for it. But it's usually some light grooming. If we know it's coming up, we'll build that way.
Yeah. So
go ahead.
Specifically there though, when we do things like that, right, and when we build a tool steel safe, that happens both from the customer who owns the design part and both us as the tool maker, right? So when we're making a mold, even if the customer says, doesn't bring up that this is a critical area, we may know from experience that one area may be challenging. We may know we may have to adjust that. So sometimes we do that, internally, because our end goal is to meet, what the tolerance is of the part. Yeah. So, sometimes we do that on our own, but, often for, certain customers, again, what questions do we ask? That's why we want to know what's important on your part.
Yeah. So we went back. So we're talking like this first scenario, Kickstarter, one part, low volume. And I would consider this low volume production because it's still like expected to be a production or something like a saleable good, right? Yeah. But it's not just a prototype like tossable, but it just has a lower life. So you're talking about using a mud tool or a mud frame, which reduces the overall tooling cost.
Yeah.
of the project, as well as a material like aluminum versus what is it like versus steel
So
usually
like a
or stainless?
P20 steel, and
Yeah.
again, it depends, how
Hmm.
many parts were expected off the tool. For
Yeah.
anything that we're talking about, up to, tens of thousands of parts, we'll do like we'll either do an aluminum
Hmm.
tool or like a P20 steel or something like that. But depending on application, right? There may be specific cases where we have a very thin piece of steel that we want to make that out of something stronger. We'll go with a different material as well. So material selection has a lot to do with cost, especially for the cost of
Hmm.
material versus and the machinability of the material. But sometimes material selection is in the mold is very important for either part quality or for strength of the materials. If we know something's going to be a troubled area, maybe we want to build it out of something a little stronger. If we know some area is going to have a little more heat, maybe we want to make it out of something has better thermal characteristics to help get that heat out of the steel or the metal. So we'll select materials of a mold based on what we need.
And so say this Kickstarter project,
Yeah.
now I have three parts in my molded project. Maybe the cosmetic side, like to create the inner outer cosmetic side, and maybe something internal like the PCB that
Yeah.
kind of mounts everything together. What type of strategies would you do if I have a low volume? Because usually, like when I think about that, I think three
Yeah.
parts, three tools. But is that correct?
So it depends, right? And often we can do what's called like a family tool. If it's
Mhm.
all the same material, if the parts, work well together, if we don't have extremely tight, dimensions on certain aspects, we can build what's a family tool in which they can all share the mold base, and where we shoot the plastic in can all come from the same area, but then branches off of a runner system to each of the parts. And in one open and close of the mold, we can make all three of those parts. Um, there's certain things that you'd have to consider, right? Like I was saying, with if there's any tight dimensional tolerances, if there's any side action in the part, I'll explain that a little more in a
Yeah.
second. Um, or if the quantities are going to be different, if you don't always want one of each of those parts, if I need 100 of these and I need 10 of these, every single time, family tool might not be the best way to
Yeah,
go.
so it's more like if it's a regular set of
Absolutely.
of parts that are like at least like a material because you can't
Like
change the
material, yeah.
materials. Yeah.
So
And now so family tool is like, I mean, how many cavities can I put on a family tool? And I know like there's a big caveat there, but what it
yeah,
like
so
is there like a size limitation where it's just like, no, this doesn't make sense anymore, Greg? Please stop asking for a family
Uh,
tool.
yeah, Greg. So I know you love to put everything in a family tool, but yeah, no. So if we have it- every time you have a plastic part, there's a couple things that we're looking at in terms of whether this fits in a mold or whether we works for our press. So one of the items is how much surface area. That's important because the machines that we have in injection molding, each of them have a different kind of tonnage. So how much pressure can they apply when that mold closes to keep it clamped closed? Based on the surface area of the parts and the pressures that are going to be as a resultant of the plastic coming into the parts, that mold wants to do this as soon as I put the plastic in.
It wants to push open, right? So and that
Absolutely.
causes flash or just a terrible day.
Or
Yeah.
a terrible day, yes, in which the entire mold breaks or something happens and we're spending hours cleaning it out. So we need to have enough clamp force to keep that closed. Also, there's a lot of in a specific press, you can have certain size molds. There's tie bars on some are tie barless, but you have a working area of how big this mold can be. So a combination of how much tonnage is in the press, how much room I physically have to lay these things out in the mold for a press, and the last one, well, there's more, but like the other major one is the shot size. So if I can only have up to a ounce and a half of plastic going through into the mold, but I got 2 ounces of parts, obviously that doesn't work as well. So um, what mold, what injection machines we're going to use has a big it plays a lot in terms of how
Yeah.
many you can fit in a family mold. So I can't just tell you a number, So if we were going to do cavitation of small parts, like if I'm making, 3264 of the same part, yeah, there's cases we can do that. Do I have a big enough press for it? That's the question. Depends
Yeah.
on all these different factors.
Yeah, and I think that's I think it's interesting, and the reason why I'm bringing family tools up is
Yeah.
that's something that I know a lot of customers don't know that's an option.
Don't think about it. Yeah.
What it does is you still pay for the milling of those cavities because like these are precision
Yeah.
milled cavities create these features. So that's still it doesn't half the cost if you're putting two parts in a family tool,
Not
but it may
100%.
reduce the cost by like a quarter or or a
Well,
third. Sometime, depending on the
yeah.
complexity of what you're milling, because you're not actually putting the creating a whole standalone tool. Even if
Yeah.
it's a mud frame, you're not using a frame for it.
So
Yeah,
in making a mold, most of the cost isn't necessarily in the materials. It's in exactly what you said. It's in machining that shape in the
hmm
materials. Let's call all of the materials are 5-10%, of the cost, but the rest of it is the labor, the time, the weeks, the hours in each one of the
hmm
machines to machine out, whether it's with CNC process, whether it's with the EDM process, whether, some other process, depending on what we're doing, a lathe or whatever kind of work we're doing, that's where most of the labor is. So um, you do have significant reductions there, right? Because I'm just now molding, machining that one piece, and I can do them all together, put them in different blocks, but I'm capturing it in that mold where you save a lot, right? So let's say that each of the part takes 30 seconds to make in the mold. Time it takes for the plastic to go in, for it to hold, and for the mold to open and close. Right? Correct. So if I have three different molds, I have a minute and a half of cycle time. Cycle time costs money. But if I can make all of those within one cycle, I've now reduced the cycle time to 30 seconds for all three parts. So they now
yeah.
share that cycle versus each of them having their own cycle. So you gain, that benefit as well. What do you lose? So that's the big caveat. So from a mold making standpoint, when I make one part, a single cavity, I have the most control over dimensions and stability in the molding machine on a single cavity tool of making one part than I do if I repeat that or add more parts.
And also probably like the gating location, right? To
Gating
like
location, where
yeah,
I'm going to put it.
gating
But
strategy.
when you think about it, when I have one part, I can machine that part to plus or minus X, in the steel for each of the cavities. However, I now have different things at play. How the plastic is traveling to each one of those gates can be ever so slightly different. The temperatures in the mold for each of those cavities can be ever so slightly different. And these different changes stack up. So when someone asks, is it easier to hit dimensions on a single cavity tool or let's say an 8 cavity, 16 cavity tool? Well, obviously on a single cavity, because in an 8 cavity
Yeah.
tool, I have to hit those dimensions on every single one of those parts that's in that mold, and everyone may have ever so slightly difference, a few tenths here, a few tenths there, different, half a degree of temperature different on this part, half a degree of temperature on this part. So there's that caveat. So the same thing goes with family tools as well. So when I make one part, the control that I have on that one part is a lot higher than when I put all three of them, four of them, however, in the same mold. So
And that makes sense. And I was going to say, I know we'll be talking about. I was going to give you a scenario on production, which I know is kind of like sky's the limit on what we can do there as well. But a lot of times when when I'm looking at plastic parts around me, for those who don't inspect plastic parts like you do once you get into a molding project where you look at every plastic part and try to figure out how it's constructed, you can actually look on the back and sometimes either see a number or you'll see kind of like these. These are off the shelf stamps that you can add the tools
yeah,
that have essentially looks like a clock or looks like a rule of numbers,
yeah,
and there's got to be an arrow pointing to a number, and that's what cavity that part was made in a tool.
yeah.
So if you see a part that has 8 in it, there was at least 8 cavities, 8 identical cavities
At
in that
least, right?
tool
It could have
when
been
it
eight of
closed and opened up.
32. Yeah.
I've seen I went and saw a contact lens case
Oof.
tool,
Yeah.
which is if you think about like how prolific contact lens cases are. Like every single box of New Solution has them in there, and I think it was an 88 cavity multi-stage tool. It was pretty
Yeah.
impressive. But it is that is not a low volume prototype tool. So
Yeah, no.
let's talk about that. And again, it's more sky's the limit, because once you go up to higher end tools
Yeah.
and higher production, and I know in one of our previous episodes we kind of talked about this too, the price of the tool becomes less important versus the outcomes, the throughput,
Absolutely.
the
Absolutely.
quality. Because that tool, like say I'm making millions and millions of products through it, if that tool is several $100,000, it's still pennies on the
Compared
product.
to the
Like it's
amount of what you're
yeah,
paying for parts over the life of it. Yeah.
yeah, absolutely. And so like where at a low volume tool where I'm making 2,000, it's dollars
Yeah.
on the product, because the tool amortizes it over such a few amount of items. So it's a very different approach, but you can go just so much higher in customization.
Yeah.
So so we talked about the mud tool, we talked about family tooling. So I've had multiple parts. Again, this is more for like lower volume production,
Absolutely. Yeah.
some middle stuff. Um, I do want to actually I want to talk about production really quickly, but it's something you hadn't mentioned, but I hear all the time when we're talking about lower mid volume, and it's
Okay.
this cost trade off is like, when do you as a tool maker suggest a automated side action versus a hand load
Yeah.
feature, so
Okay.
something that is
That's
a
a good.
manual
Yeah, it's a good
intervention.
topic.
Yeah.
So, a lot of it comes to do with labor and the amount of time it physically takes to take that part out.
Hmm.
So the difference, I'll talk about that a little more. So hand load versus an automated, slide or lifter or type of side action feature. What that means is, so back to our kind of, movable and
Hmm.
non-movable side of the tool. One stays straight, one, opens and closes. If there's some features that need to be pulled out in this way, let's say there's a hole going through the part here. If I pulled that out, I would break that. I can't push that part out without getting that piece out. So that's
Yeah.
that's side action. So let's say we have a cup and the cup has a giant hole in it on the side. That would be side action to make that hole. So how do we do that? First of all, we try to avoid it as much as possible if it can be, because there's nothing more simple than opening and closing a mold, and keeping it that way. So if there's a trick and there's no reason to have it, on the side, if there's a design technique that, can be used, some people just may not be familiar with them, we will first suggest that unless it's something that
And
needs to happen.
the class example there, right, is a snap tab
Oh,
feature
absolutely. Yeah.
creates a undercut. So what you're
Yeah.
talking about, it'll create like essentially a shadow where like the A or B side of the tool couldn't create that undercut.
Yeah.
But if you put a hole,
Like a pass through, we
yeah,
call
where the
them. Yeah.
shadow is, then one side of that tool can literally just have kind of a rectangular peg
Yeah.
in it that'll go and create that feature, still approaching head on, and that's
Absolutely.
a pass through,
Yeah.
but it's a way to mitigate that undercut.
Now, if it's a hermetic seal and there can't be that hole or
Yeah,
there's
yeah.
reasons,
If
then
like
we
I have
start
a like
talking side action.
IPX6 part or something, yeah, I can't have holes in my
Absolutely.
product.
So,
Yeah.
side action specifically, um, you can do it a couple ways. One, you can put something steel that we call them hand loads, that physically, when I eject the part out of the tool, that piece of steel comes out with it. And then I manually, as the operator, remove it.
So an operator is watching the press. Like
Operator is
they're
100%
watching
working
and,
the press.
and swapping
Yeah.
out. And are they kind of like press is open, and they're sitting there with the part, taking out that piece and putting it back in, and that's
So,
kind of like the op. Yeah.
so typically, yes, press is open. Operator reaches in, grabs the piece. Maybe it's presented with some ejection. When the operator activates that, pulls out, pulls on the side. But a lot of the times too, this could be done with robotics. So again, depending on scale and
Mhm.
size of this, a robot may be taking out and presenting it. It really, really depends on the situation. But then there is an operator physically then removing that piece of steel that created that side action, re-prepping the machine to make the next shot, putting either, usually we'll make several of those hand loads so that they equalize with temperature, and put another one in while the machine is closing. Maybe they'll remove the one that came out on the part, etc. Depends really on what the cycle is and how we're doing it. Puts that back in. So that specifically, that is a labor intensive process. So if you came to me with 1,000,000 parts, 10,000 parts, and said, I want to do this, well, we literally have to run the time study of how long we think this is going to take. We can't, tie up, someone for a month to be doing this. So a couple hundred parts, 50 parts, it makes a lot of sense to do,
Yeah,
hand loads.
and that's because a hand load to create a side action using a hand loaded core is cheaper on the tool, but it's
Then
more
doing,
expensive on the per piece because you still have operator
Yeah.
labor against the per piece. But if I do an automated version, and we talked a little bit about automatics, but something that is opening and closing either along with the action of the tool opening and closing, or is automated, hydraulic, or electrically operated to screw or unwind or do whatever it
you're
needs to
throwing
do.
it into the
It's
part,
costly.
throwing into the mold and taking
Yeah.
it out of the part. Yeah,
It's costly, but I can run my tool overnight.
yeah, absolutely.
Yeah,
and so
without
those
a
are
person.
those
without
are
operator.
those are the considerations, right? And so time, money, it really comes down to that. So when we're talking, automated processes of removing side action, we're talking slides, we're talking lifters, and so whether it's from the open close action of the mold, maybe there's ramps on angles, so there's rods going into the B side. So as the mold opens, the rod stays, stationary from the station side, but it forces the slides to come out. Sometimes we use the ejection system of the tool to activate the slides to open. Sometimes there's also a unit that operates on itself, whether it's for a pull or whether it's for a rotational type
like
of deal.
a screw unwinding.
Yeah, like a screw
device.
unwinding. So,
Yeah.
that could be powered on its own, whether through hydraulics, electronics, pneumatics, etc. So
I will
price
make a
gets up
joke
there.
about one of the clever things I've seen, which was kind of a mix of a screw unwinder and a manual intervention, was a tool maker running a tool where they had to get a specific thread feature, and they had their power drill.
Oh god!
So they basically created a junction on the side of the tool
to put it on, and then
with a little hex feature. So they just unwound with their power drill and opened the drill. But this is also when this is a molder making a product for themselves. So
Yes.
they own the tool.
They
know
understand
the
the
design.
risks,
They understand
yeah.
what they're doing, and so they're kind of experimenting. But I put that in the same realm. And this is a whole other subject of 3D printed tools.
Yeah.
Which for the most part is something it's not impossible to 3D print a core
No.
like a core cavity, but there's a lot of reasons why you don't necessarily want to do that, including surface finish,
Absolutely.
the count of parts. And I know we were talking about being someone who acts more like a contract manufacturer. It's about liability and repeatability. I'm making a promise to my customer, and using something that could potentially break or give a poor surface finish or have some
Absolutely.
challenges as a raw fundamental part of my tool is something that I don't necessarily want to pass that risk to my customer. So we're usually going to cut the metal instead.
Yeah, there's 3D printing and additive manufacturing comes into play in a lot of different areas in injection molding, and not all of them fit. And there obviously is the risks of the costs and the quality risk of when to use it, when not. But there's a couple of different types of way it can be utilized, right? So there's things called digital ABS that is used that
you can print a ton of that stuff.
You can print digital ABS and make a and B kind of mud frame type deal.
Yep.
Get 100 parts out of it in a molding machine, and then you're done. So that's one way, and that's a plastic that can withstand higher temperatures that you 3D print.
And that's a lot of that. So digital ABS it's a polyjet material,
Yep.
And I used to do a lot of printing of that particular material and did prototype molds and stuff. And again, usually the person receiving it was a molder themselves.
Yes,
and that's a big caveat was they were taking the risk on themselves, usually for a project, understanding that I may get one shot in, and due to the pressure and the heat caused,
cracks
my whole
the whole
mold
thing,
just
and it's just
blast out the side. I remember talking to someone that's He's like, when I mold with a 3D printed mold, I'm standing with my air gun, just blasting air as it's
Just make sure
closing,
it's
just straight onto the tool, just trying to cool it down as much as I can. And
yeah.
usually even then, they're if there's longer features, protruding features that could be fragile on the 3D print, they're still CNC milling out those
Yeah.
features and using them almost as a insert into the 3D printed insert into the mold itself. So
Yeah. So I
uh,
mean,
yeah.
you can get into it, and like, how quick can you make those parts? I mean, you can make that mold very quickly and then throw it in a press. You can have very fast iterations. It costs a lot of money to do it, and you're getting what you're getting. There's only so much you can do with it. But then you get into like 3D printed metals, and okay, so people are like, oh, well, why don't you just 3D print the whole mold? Well, okay, to an extent we can, do certain things, but what do you want your part to look like? So there's some fancy 3D printers out of there that combine, additives, laser sintering, and CNC milling. So there is a kind of CNC, a finished surface that is more applicable to, the molding world,
Mhm.
where 3D printing and the cured laser sintered metals, where they have had the hugest effect. The largest cost driver and factor time wise in a mold is how long does it take to cool. So let's just picture
Particularly production tooling.
production tooling. Yes,
Yeah, particularly
in
production.
prototype and short run tooling, you're paying a lot per part. So cycle
Yeah.
time isn't as big of a concern unless you're trying to develop a production million part ready, and then you want to prototype exactly, do more bridge tooling and prototype exactly the situation that you're going to have to get to these points. But in that case, let's say here's my isometry notebook here. So this is my mold. So let's say I have some sort of feature in here. I want to put water lines in this mold. I can't go through the feature, right? So I'm going to drill holes,
Yeah.
going through.
For the audio version, like if you think about the mold as a rectangular
Oh,
block.
sorry, I'm holding a
Yeah.
rectangular block, and
I'm
then
holding a rectangular block, then
Yeah.
I could only drill line of sight, and that's kind of
Yes.
how drills work, right? Like I'm going to be cutting into a line of sight, so in order
Absolutely.
to make a cooling channel that needs to make a turn, I'm drilling
have to
straight,
avoid it.
and then I
Yeah,
drill
I'm
on the
drilling
other
straight.
side, and then I plug off one end or do something else. Yeah.
Absolutely. So for that now, so to say I want to get better cooling,
Mhm.
well, I can get closer and risk cracking the wall, but there's still, for contours, unless it's a straight wall, I'm not going to get even cooling. But with conformal cooling and 3D printing, I can print that channel to hug, the outline and the surface of the part, and literally get the cooling to the optimal location everywhere that I need it around the part. And that's one of the areas where 3D printing currently is being highly
Yeah.
utilized to get better finished parts and get better cooling, faster cycle times, and it's really pushing the boundaries of what we used to be able to do in injection molding.
Yeah, and I spent a lot of my career talking about when to use, particularly on the metal side, metal printing versus machining, and it's usually about the invisibles. To your point,
Yes.
which
Yes.
is it's not if I could already access that feature with a tool, I
Yeah.
can probably get a highly qualified material and get a tool set to create that surface finish and prep it exactly into a tighter tolerance than what I could do with a 3D printing method.
Yeah.
However, if there needs to be a lattice structure or topology
Yeah.
optimization or more organic curvature or a super deep channel that would just be a pain to EDM,
Yeah.
or internal internal curvatures and these cooling channels, that's where 3D printing just shines. And it's just such a strong manufacturing method
Absolutely.
to achieve that.
And another area where it's going is for venting. So typical venting is, now venting. What is venting? Okay, so
I was going to
let's
say,
go
like,
there first.
we're got a little off topic, but I love this. I'm
Let-
geeking
let-
out here. Yeah.
Yeah, let's go back to it. So, okay, tool opens and closes, right? Now, when I inject plastic into that, what is in the mold, the cavity in the mold, there is air there that needs to be displaced. So if I have nowhere for that air to go, it makes it very difficult to push plastic into that part, leads to various quality defects. So what I have to do is put venting around the part. We do that on parting lines, and we can also do that where ejector pins come into place. But what that is every single plastic will flash. If you have a gap of, let's say, tenths of a thousandths, like at some point, a plastic will flash. It's all about um, how much force it needs for that plastic, the fluidity of it to push through, a tiny face. With venting, every plastic, we have kind of a number where air can go through the hole, but plastics don't. So when we're doing venting, we want to creep up onto that specific vent size so that we're not flashing through that vent, but we're allowing the air to escape. So we'll do that around parting lines. We'll do that on ejector pins where necessary. But sometimes you get to specific places where there's areas in the mold that are neither where there's going to be ejector pin or where there's going to be a parting line, where we know there's a possibility for air to get trapped, which is going to then cause some quality defects.
That's based on also the flow of the material. So where it's gated, my material's flowing through, and at some point, if there's nowhere for the air to escape, this plastic is essentially pushing against the bubble.
Yeah.
And something's going to win.
Something's going to win.
And
now,
sometimes
the bubble may go inside the plastic, right?
The bubble may it may void. It may turn into plasma.
Yeah.
And
that's
scorch.
Always fun.
Or it may just say, nah, the plastic's stopping here, and you get an incomplete feature on your part. Yeah.
Yeah. And so that's another area where 3D printing and laser sintered metals has made huge advances, in which you can now put porous venting in certain areas of parts where you never could before.
So I could sinter a metal to like a 98 or 99% density that has just enough where the microstructure of it allows air to move through.
But plastic's not going to get through it. Yeah.
So, I want to, we've covered a lot of subjects on this, on topics of molding. And I just love this idea of like where molding is, that the tool is its own thing. I think that a lot of, a lot of people, when you're new to injection molding, don't realize how many pieces and components actually go into the mold tool. They think it's just the core and cavity side.
Yeah.
But it's got a lot of complexities, and there's also a lot of strategies, whether you're doing that low volume. We didn't talk too much about the high volume production side of things, but as you mentioned things like multi-cavitation, where when I close and open, I get more parts out with the same amount of time or overhead for that. We talked about different venting strategies, automating side actions for overnight activities, and even material, materials that can withstand the duration of those parts. I know there's something I want to follow on with you, and maybe we could do this in another interview, is talking about quality and measurement, and what is how is that assured on the manufacturing side of molded parts, because there's a difference between what I'm milling, right, and what the plastic's doing. You can't tell nylon to not be nylon, or PBT to not be PBT there. So maybe we could do that as for a follow on. But for the end of this, talking about tool design, talking to customers, do you have any sage advice for people, whether they're new to molding or more experienced, that you just kind of want to give as a reminder, or just say, hey, here's a cool tip?
Well, so I guess the sage advice, and this ties in, to Xometry, not just, manufacturing and injection molding in general. It is never too early to bring in your injection molding company, your manufacturer, into the discussion of how you design your part. A lot of newer companies, a lot of people that just design a part, I don't want to say in a bubble, but just design their part and then hand it off. Have a conversation with us up front. We will gladly discuss, any of these nuances of, how a part. Give us your very early, Rev A model, that's beyond prototype that you've 3D printed. Let us look at it, give you some feedback, so we can tell you, hey, did you think about this for when we do, you can waste a lot of time, right? So that's really the biggest stage information, again, is never it's never too early to bring, someone like Xometry into the picture to discuss how you're going to injection mold your parts.
Absolutely, and I think that's amazing advice because
Yeah.
it's not just that you may be thinking about molding, so you're working on this molding design kind of
Yeah.
and putting it up on the pedestal. So it's like it's until it's through
Yeah.
my CDR, I will not talk to a manufacturer.
Yeah.
It's also about there's optionality, right? There's
Absolutely.
sometimes other ways to approach your product depending on your time, scope, and cost. And you're finding more and more that tooling is actually getting cheaper. So sometimes
Yeah.
some of these strategies that you're talking about for low volume tooling can be a great way to enter the market early and bridge
Absolutely.
your product development cycle as you move to validate and get to like a more complex production tool. But yeah,
Yeah.
I really think that is important, especially when you're talking to your manufacturers. When we're giving feedback on it, it's not criticism of the person or
No.
designer. It's about like we want you to be successful.
Yeah.
And this is the advice to make this product successful. The outcome successful for you, your customers, your market that you're serving.
Yeah.
So yeah, we like to be open books
We're
there
here.
because
We're
we have
ready.
perspective.
You know, call me up for some information. It's a smarter customer makes a smarter, supplier, right? So when they was a customer who's more educated in injection molding because they've asked us certain questions, they're going to design a better part. It's going to be easier for us to manufacture. We're going to have less headaches. They're going to have less headaches. It's going to be a shorter, time from, the sketch on the napkin to putting it on the shelf and selling millions. So, bring us in as early as possible.
Awesome.
Absolutely.
Well, again, Matt Magnifico, thank you so much for being on this episode of Manufacturing Explained.
No problem, Greg.
I love the conversation, and I definitely want to bring you on for more convo on the assurance end and some of that production style stuff too.
Absolutely.
Thanks so much again.
Thank you, Greg. Glad to be here, and look forward to the next one. Really appreciate it.
Awesome. Have a good one.
All right, you too.
Manufacturing Explained is a Xometry production. Xometry offers instant quoting in over a dozen processes from 3D printing to sheet cutting to machining to molding. Xometry is your one-stop shop for manufacturing.